Everyone, welcome back to SAT Math Question of the Day. Here's our question. Please try it, pause it, come back, and we will try it. Okay, here we have a little bit of a table. Oh yeah, it says the table. The table shows the most commonly spoken 5 languages in the world by native and non-native speakers in millions. Aha. According to some study in 2013. If the relative frequency of Spanish non-native speakers to all non-native speakers, well, 4.8% approximately. Yeah, they don't tell that. How many non-native Spanish speakers in millions were there in 2013? So this is sort of a backwards question. They're telling us the conditions under which there are non-native Spanish speakers, and we have to figure out what the actual number is. Okay, so Seth is just there. There we go. You want to find the relative frequency of Spanish non-native speakers. So we'll call that X to all non-native speakers. To all non-native speakers, right, exactly. And that's this thing called blue underline thing. So, yeah, you have to be careful which numbers you pick off here. But essentially, it's just reading what they want the ratio to be. And they want it to be Spanish non-native speakers to all non-native speakers. So you just read the table, pick the numbers off. So, yeah, then you have to solve for X. And you know that X divided by 1237 has to be what they tell you, which is 4.8%. And we have a calculator. So, the calculator definitely will be coming in handy. Seth's doing it without a calculator. He's old school. So, it would be 0.048 times 1237. And it would be about 59. So, Seth's right without the calculator. Good job, Seth. It's about 5% of 1200. Right, yeah. Which is about 60. Yeah. Great. Okay. There's really not much to this.
The follow your nose problem.
Yeah.
The follow your nose problem with a table with missing data.
Right. Yeah. Yeah, and applying the definition of relative frequency. Right. Yeah. Applying the definition of relative frequency.
Yeah. The relative frequency of non-native speakers of all languages, all non-native speakers. So we only look at the non-native column.
Yeah.
And the problem is only about the Spanish non-native column. Relative to the total non-native.
Yeah, so it's just follow your nose, follow the definitions, be careful which numbers you take off the table, and then solve for the equation. Because they wanted a relative frequency is a ratio. They're basically saying, what is the ratio of? They didn't really have to say relative frequency. They should have said, what is the ratio of
relative frequency?
Yeah. What is given the numbers in this table? What is the ratio of X to the total number down at the bottom? So that's it. Okay. So I guess we're done. Okay. Of course, calculator helps. Calculator helps. Okay. I guess that's it, right? So let's see how they do it. Let's see how they do it.
Should we show them how to use a calculator? Or?
No. I don't think so because it's no. People have been using calculators.
Type in the 1237 times 4.8%. Calculators have a percent input, don't they?
That's okay. That's Seth. You make a good point. Let's see. This is the calculator. No, the calculators do not have a percent input. I don't think so.
Well, some of them do.
This is. We just want regular calculator, don't we?
Yeah.
There it is. Regular calculator. No, there's no percent input. Functions.
Well,
Functions. Let's see.
so then you have
Functions.
to know that 4.8% means how much? 0.048,
That
also
is
known as 48 thousandths.
right. Um, that is a good point. Now, how do we get out of the calculator? Oh, I see. We don't have to get out of the calculator. Right. That is a good point, Seth. That um, to do it, it's 4.8% times whatever it was, 1237. So in order to do this, 4.8%, you can convert to a decimal, 0.048 times 1237. That's a good point, Seth. Or you do
That's
44.8
because point oh
times
point zero
1237
one
divided by 100.
means 1 in 100. It's the same thing as 1%.
Right. So either one, you can convert 4.8%
Yeah.
to 0.048, or you do 4.8 times 1237, and then you divide by 100.
Well, this uses the fewest keystrokes.
Yeah. That is something to keep an eye on. Let's clear all drawings. I wonder, there's no way they had, as one of the answers, is there any way that they had 600? Oh, yeah, they did.
Oh
They
yeah,
did. They did.
could
They
get
did.
off
They
off
did.
by
Yeah. Yeah. Yeah.
off by 10 times.
That's interesting. Only 10. It's interesting because if you make the percent wrong, you're off by 100 times.
Yeah.
Yeah. Yeah. Yeah. Yeah.
But if you're off by 100 times, you'd be over 5 billion is the total. And
Oh, I see.
5 billion.
Well, okay. The decimal. I see.
Yeah.
If people convert the percent wrong instead
Mm.
of 4.8, and when you do 4.8%, if you change it to 0.48, which is wrong, then you're off by 10. Oh, right. That
Yeah,
is a
yeah.
common
Right.
error. That is a common error.
0.48 is 48%.
Right.
That's
Yes,
almost a half.
maybe it's better to do 4.8 times 1237 divided by 100. Maybe that's safer. This way you don't have to. This way you may not. Because you could make a mistake, even a stupid mistake, if you're not concentrating, and write 4.8%.
Well, I think it's faster to estimate and then do it without a calculator because
Yes.
the
Yes.
choices are far apart.
Right. That is true. Or you do it the other way. You do a calculator, and then you verify if the answer makes sense. That's probably more of a modern way of doing it. Is you get the number 59, and then you say 59. Oh, is that about 5% of 1237? And it is about 5% of 1237 because you can even make this 1,000. Right? And just to see if you're right, what's 5% of 1,000? That would be about 50. So then you know you're sort of right. That's really important. You're right. When there are percent problems, use the calculator all you want, but then make sure the answer makes sense. And then here, this answer wouldn't make sense. 5% of about 1,000 is 600? No way. Good point, Seth. I'm glad you mentioned that. So let's see how they did it. Okay. How did we do it? They didn't tell us, but we'll get a super hint. Then let's just get all the hints out. Let's just get the answer out. We gotta cross that out. Let's just get all the answers, and then we'll go through it. Okay. So what they do? Let's create a ratio. Right, of course, a ratio. Yeah, it's exactly what Seth did. Exactly. Yeah. Yeah, that's it, right? And we can convert that to a decimal, which is 0.048, right? That's exactly how Seth did it. Pretty good. To solve, then you solve for x, and that's it. So, yep. So that's about it, right?
That's it.
That's
That's
it.
all it
Okay,
is.
everyone. So have a great day. Seth is a PhD in math from MIT. He was a professor of computer science at SUNY Open. He's now Professor Emeritus, retired. I'm Seth's brother, Joel. I have a PhD in mechanical engineering from Columbia. We're here to hopefully offer different approaches and how to do math SAT questions. And then one approach we suggest in terms of studying for the math SAT is to go to Khan Academy and take their digital SAT course, which has about 600 to 700 math questions that is sanctioned by the College Board. And they basically tell you what you need to know for the test. You practice on those, and then you practice on actual practice SAT tests given by the College Board or on the College Board website. So I think that's it for today.
Yeah, that's it.
We relish the comments that you give us, so please comment as you see fit. and
Yeah.
if you have any SAT math questions, please email them to us at satmathquestion@thedayatgmail.com. Okay, everyone, have a great day. Bye.
Okay, thank you. Bye bye.
Bye.